This is section 8.2, graphs of functions. Remember I said we were going to mainly stay with functions, but we've got a visual method for determining whether a graph of a relation is a function, and it's called the vertical line test. Remember, we do not have a function if I've got two different ordered pairs that have the same x value, because if you graph those, then they would be right above one another. If you connected them, they would be a vertical line. So I can use a vertical line, scan it across a graph, and if I hit it in more than one place, it is not a function. So let me take my vertical line here, and in problem A, if you'll notice, I can hit in two places. I only have to do it once. So A is not a function. Now with B, if you'll notice, as I scan through, I try my best to hit it in more than one place, and I can't. So B is a function. C, right there, stop. It is not a function. D, it looks like that is a function. E is not. I can hit it in two places, there and there. I can move it over a little bit, and I could hit it in more places. So that is not a function. Let me move it on over this way. That's sort of cool. I can only hit F in one place, so that one is a function. So that is a vertical way, or a visual method, to determine whether a function exists by using the vertical line test. Now, if given an equation where y is raised to an even power, you will not have a function. Remind me, I will talk about that a little bit on Thursday when I see you next. Now here it says graph the following in your calculator and determine if y is a function of x. So in this one, I would have to add 7, because when I go to y equals, it has to be in y equals form. So let me clear that off. So I would have x squared plus 7, x squared plus 7. Let me do a zoom 6. I'll move it down a little bit. So window, go change my y values to make it a little bit higher. When you start making these numbers higher, you need to indicate the tick marks, the space between them, a little bit higher. So let's see if we get a better graph here. So move down. So if I could get this vertical line over there, which I can't, but imagine if I could take that and I could scan through, I could only hit it at one place. So that is a function. This one, number 2, it's already solved for y, so that's x minus 1. And let me take it back to zoom 6. Again, take your vertical line, scan through, and I only can hit it in one place. So that's a function. Absolute value of x. We can graph those, but I have to go to math first, over to numbers. So let me cursor over to number. It's because I've got to get abs. Some of y'all, depending on your calculator, you'll have the ABS with the parentheses. The newer models will have just absolute value. So let me place in x. I'll get out of that. Ask it to graph. So that sort of looks like D that we had a little bit earlier. And if you take a vertical line through, you only can hit it in one place. So yes, that is a function. Now we're going to talk about interval notation. Interval notation is a convenient notation for number line graphs instead of using inequality. You express the following in interval notation.